In this video, we're going to quickly take a look at powers of I. So, first note that I to the 0 should be 1. Remember, anything to the 0 is 1 except for 0 to the 0, which is undefined. So, it would make sense for I to the 0 to be 1. Of course, I to the first power would obviously be I. Pretty much by definition, I squared is negative 1. So now what happens for I cubed? Well, I cubed should be I squared times I because we want our properties of exponents to work like normal. So I squared is negative 1, so I cubed is negative I. But then look what happens when you get I to the fourth. I to the fourth is I squared times I squared, so it's negative 1 times negative 1 is positive 1. So I to the fourth, you're back up here at 1. I to the fifth would be I to the sixth would be negative I, and so forth. And so we get a nice little cycling pattern. I to the 0 is 1. I to the first power is I squared is negative 1. I cubed is minus I to the fourth is back here, so that makes I to the fifth here, I to the sixth here, I to the seventh here, I to the eighth is back here, I to the ninth, I 10, I 11, etc. So it keeps cycling. What do you notice about all these numbers, 0, 4, and 8? Well, they're multiples of 4. These are 1 more than a multiple of 4. These are 2 more than a multiple of 4. And these are 3 more than a multiple of 4. So all we really have to do is divide the power by 4. So for example, like if we have 47, and we want to look at I to the 47th power. Divide 47 by 4, and we get a remainder of 3. So this says 47 is 4 times 11 plus 3 more. So I could rewrite this as 4 times 11 plus 3 more. So I can make this I to the 4 times 11 times I to the third. So this is I to the fourth to the 11th times I to the third. But I to the fourth is 1. 1 to the 11th is 1. And so when we get to here, we notice that you just get I cubed. So what was really important? It was important that we divide by 4 because I to the fourth was 1. But the 11 didn't really matter. What's important is the remainder, 3. So all we have to do is divide there. Now what if I have a really big number? Okay? Well, notice that this is I to the 3, 4, 8, 7, 6, 5, 4, 8, 300 times I to the 21st. The point is, once I get what something that ends in 2 zeros is divisible by 100 and hence divisible by 4. So all of that is just 1. So when I divide, in other words, when I divide this whole big number by 4, it's the same thing as this. As far as the remainder goes, it's the same as if I just divide the last 2 digits. So all of this is the same as just I to the 21, and I to the 21 is just the same as I to the first, which is I. So, bottom line, all you have to do is take the power, divide by 4, look at the remainder, and the remainder is either 0, 1, 2, or 3. Then if the remainder is 0, if the remainder is 0 when you divide by 4, then you get 1 for I out of that power. If the remainder is 1 when you divide by 4, you get I. If the remainder is 2 when you divide by 4, you get negative 1. And when you divide by 4, you get a remainder of 3. Then it turns out to be minus I. So this says n is congruent to 0 mod 4 means the remainder is 0 when you divide n by 4. That's what that means. And so there we go, and you get one of those things. So you always get, for natural number powers of I, you always get either 1, negative 1, I, or negative I. You get one of those 4 things, and you can tell which one by just dividing that power by 4.